All right, so we know how to kind of write out the reaction rate and what it's equal to and all those equations, but how do we use them in problems when we're talking about actual rates? So we're going to review how to write what the rate of the reaction equals, and then we'll practice applying it in this problem. So we have our reaction up here. So the reaction rate is equal to the negative reactants, right? So we're going to do change, and we're going to use concentration here because they're giving us both moles and liters. So change in concentration of pH 3 over change in time, and we got to divide by 4, which is equal to the change in the concentration of P4 over the change in time, and that's equal to 1/6 the change in H2. Whoa, that looks really bad. H2 over the change in time. Now remember, for each one of these, just the delta portion, like this, is the rate of pH 3. So keep that in mind. So they're giving us the fact that this many moles of pH 3 are consumed in 2 liters each second. So if we want to be in molarity per second, we could also use moles per second, but you got to be really clear about which one you're using. So say we're doing molarity per second, that means that the rate of the rate of that's going down for pH 3 is equal to 0.0024 molarity per second, right? So that's molarity per second. If we were just talking about the moles, I could say 0.0048 moles per second, but molarity per second is a more common unit. Okay, so now the question is, what is the rate of this one and the rate of this one? So when I'm plugging these in, I'm going to do this the mathy way. You can think logically, and if that works for you, that's totally fine. I never can do the one that I want. Okay, let's see if that worked. Okay, well now that's silly. Let's just make that small and then we'll erase all this. It's a work in progress, guys. We're figuring it out. Okay, great. So let's first find P4. So we can do this 2 ways, right? We could do the math way or we could logic it. I'll actually show you both. That'll make things good. Okay, so let's take the pH 3 and the P4 bits. So I'm going to have negative delta pH 3 over 4 delta T equals the change in P4 over the change in time. If this looks confusing to you, think about it this way. Negative 1/4 times the rate of pH 3 equals the rate of P4. Now never write it like this on AP tests. This they will not understand. But just to show you, this whole thing is the rate of pH 3 and this whole thing is the rate of pH 4. Okay, so then if I know the number for pH 3, I'm going to plug that in. So I want to show you what it looks like in the actual way we're supposed to do it. So let's plug it in. So we're going to have negative 1/4 times our rate, which was 0.0024, equals the new rate, 0.00, whatever P4's rate is. The change in P4, that looks terrible, or change in time. Okay, so let's do that math. So 1/4 of 24 is 6. So it's going to be something to keep in mind too. So this is being consumed, which means it's going down. So this would be negative here. It's going down. Going down that fast. Whatever. We want to make sure it's positive at the end. So then 1/4 of that should be equal to 0.0006 molarity per second for change in P4 over change in time. And we want to think about it logically. This should be going down slower than this. This should be going up slower than this is going down. So one more time. Because this is 1 and this one's 4, this one should be slower and this one should be faster. This should be 4 times as fast as this, and it looks like it, so that makes sense. Okay, so that's like the mathy way. Maybe we should have done them opposite because the other one's going to be easier mathy way. So let's see this same idea. So let's erase this and this. And now we're going to set it equal to 1/6 times the change in H2 over the change in time. So this time, to get this rate by itself, sorry, I'm on space. I'm going to have to multiply this 6 to the other side. So we're going to have -6/4. Okay, so then we do that math, which is like 3/2. So we add on a 0.002, should be equal to 0.0036 molarity per second. And let's double check. This should be faster than this, and a rate of 2 to 3 if we simplify the 4 to 6. All right, so that's how we think about it. So we would say P4 is equal to 0.006 molarity per second, and H2 is equal to 0.0036 molarity per second. So this one's the slowest. This is 4 times as fast. This is 6 times as fast. So it's just thinking about these ratios, essentially. If I wanted to know the total rate of reaction here, it's going to be equal to anything that has no coefficient, which means that this is also the rate of reaction, if I wanted to say that. Okay? This is 6 times the rate of reaction. This is 4 times the rate of reaction. So our answers would be 0.0006 and 0.0036. Hopefully you found this not too confusing.